Have you ever got a problem with fractions? I know most of you hated this topic as much as you hated math. This could be one of the most hated math topics since elementary. How much more if this concept comes with a bunch of letters and numbers with it? A fraction with numbers and letters is called rational expression on higher math. If a fraction brought you burden when dealing with it during elementary class, then I must think now that it could do the same for you on this lesson. Enough of the negative thoughts. Well, I'm here to lessen or even remove your hate when it comes to this topic. This lesson is just a review discussion which will help you understand fractions and rational expressions well. But before that, take a look on the objectives of this week. Some of these will be carried over on the next videos. At the end of this week, you are expected to represent real-life situation using rational functions. Distinguish rational function, rational equation, and rational inequality. Solves rational equations and rational inequalities. On this video, we'll be discussing about the following: review on fractions, review on factoring, simplifying rational expressions. I know that you already faced fractions during elementary days. Back in those days, maybe your teacher defined fractions as simply as part of the whole. But on higher math, it was defined as numbers that were represented by the quotient of two integers. Fractions are also simplified to lowest term. Lowest term is the lowest possible representation of a fraction using the smallest numbers. Let's say, for example, 24 over 36. To simplify this fraction, you need to find the greatest common factor of the numerator and the denominator. In this case, the GCF of 24 and 36 is 12. So you need to divide the numerator and denominator by 12 simultaneously to obtain the simplest form of the fraction. So 24 divided by 12 is 2, while 36 divided by 12 is 3. That's why the lowest term of our given is 2/3 or 2 over 3. Fraction has two pair types. One is called similar, whose denominators were same numbers, while the other one is called dissimilar, whose denominators were not same numbers. For adding or subtracting similar fractions, you just need to operate the numerator and then copy the denominator. Let's say, for example, 2/5 plus 2/5. Since the fraction have both denominators of 5, we just need to operate 2 plus 2. That's why the answer became 4/5 or 4 over 5. The similar fractions, on the other hand, is harder for some students. So I'll teach you an easy way to deal with it. Let's say I have 4/5 plus 3 over 7. For this, we'll be using cross multiplication for it. So denominator 7 will be multiplied across 2 numerator 4, which results to 28. Then 5 multiplied to positive 3, which becomes positive 15. After that, multiply the denominators, so 5 times 7 is 35. Then complete now the fraction by adding or on sometimes subtracting the numerator. In our case, it is addition, so 28 plus 15 is 43. And then copy the denominator. If possible, transform the answer to lowest term. Unlike addition and subtraction, this operation is easy to do because of the so-called cancellation technique. Cancellation is a process of reducing the fraction to lowest term. It is done by just dividing same factors between a numerator and a denominator. For example, 9 over 14 times 21 over 12. 9 and 12 can be cancelled to 3 and 4 because they were both divisible by 3. So 9 divided by 3 is 3 and 12 divided by 3 is 4. 21 and 14 also can be cancelled by 7. 21 by 7 is 3 and 14 by 7 is 2. After cancellation, you can now multiply all numerators and all denominators. So on our example, 3 times 3 is equal to 9, and 2 times 5 results to 8. Now for division, you just need to get the reciprocal of the divisor or the second fraction before moving to the multiplication process. Reciprocal is the process of reversing the position of the numerator and denominator. Rational expressions are fractions made up of algebraic expressions. This means that it is composed of letters and numbers like x squared minus 2x plus 1 over x minus 1. Definitely, since it is also considered as a fraction, it is also being simplified into lowest term. This process can only be done by just reducing both numerator and denominator into factored form. So for that, we need some factoring techniques. Factoring is a process of extracting expressions from a given one. The extracted expressions must result as a product equal to the given. Here are some common factoring techniques. Among all of these, factoring quadratic trinomial give student a hard time to complete. Basically, GQT or quadratic trinomial has two forms. The type 1, which is x squared plus bx plus c, and type 2, which is ax squared plus bx plus c. Type 1 is a form of GQT without a constant on the leading term, while the other, type 2, has a constant on its leading term. A, B, and C on the forms are just representations. These are actually numbers on the real figure of GQT. So let's take GQT type 1 first. Let's factor x squared minus 5x plus 6. For this type, you just need to think of numbers that if you multiply will result to the C, and if you add will become B. So what is B and C? B and C are the constants present in the trinomial. B is the constant of the second term, while C is the constant of the third term. So therefore, we'll be thinking numbers that if you multiply is 6, which is the C, and if you add is -5, which is the B. And those numbers are -3 and -2. It is because -3 times -2 is +6, which is our C, and -3 plus -2 is -5, which is our B. So since we satisfied what we need for the conditions, then the factors are written as x minus 3 times x minus 2. So it's your turn now. Pause the video and try if you will have same answers. Here are the givens that you will be factoring. 1x squared minus 2x minus 24, 2x squared plus 10x plus 9. The first given has a factor of x minus 6 and x plus 4. If you will check it out, if it satisfies the condition, then -6 times +4 is -24, which is our last term or C. And -6 plus 4 is -2, which is our second term or B. Number 2 has a factor of x plus 9 and x plus 1. It's because it satisfied the condition we need. 9 times 1 equals 9, which is our C. And 9 plus 1 is equal to 10, which is our B. So now let's move on the second type of GQT, which is type 2. So here we need to factor 6x squared plus 7x plus 2. In this type, we have what we call a constant on the leading term, which is A. And on our example, that is 6. It also has B and C, which were 7 and 2 respectively. There's a bunch of ways on how to factor it, but conventionally, trial and error was used for it during junior high school years. Actually, there's a way that has a defined process to follow on factoring this type. It is called the AC method. For this, you just need to multiply A to C. So, 6 times 2 is positive 12. After that, you will rewrite the expression without A and using the product obtained, which is 12. So our given will become x squared plus 7x plus 12. Again, A is removed. Just copy the second term because we didn't take any step for it. And then the 12 is used instead of 2. Then, factor the new expression using our way on GQT type 1. So, think of numbers that if you multiply is 12, which is C, and if you add is 7, which is B. And those numbers are 3 and 4 because 3 times 4 is 12, which is C, and 3 plus 4 is 7, which is B. So the factor will be written as x plus 3 and x plus 4. This is not the answer yet. So for the next step, you need to divide our A from the originally given, which is 6, to each of the constant of the factors. If not divisible, just get the lowest term. So 3 over 6 has a lowest term of 1 over 2. So the first factor will become x plus 1/2. While 4 over 6 has a lowest term of 2/3, then the second factor will be x plus 2/3. In the event that after doing all, still a fraction emerges, you just need to bring up the denominator beside its corresponding x. So, on the first factor, bring up 2, and on the second factor, bring up 3. The result will be now 2x plus 1 and 3x plus 2. And that is the factor of our given. Again, your turn. Pause the video while factoring the following. Number 1, 3x squared plus 5x minus 12, 9x squared minus 9x plus 2 for the second number. The first given has factors of 3x minus 4 and x plus 3. The process of obtaining it is by, number 1, multiply 3 to negative 12, which is negative 36. And then, rewrite the given as x squared plus 5x minus 36. After that, think of factors of negative 36 that sums up to 5. And that is negative 4 and 9, because negative 4 times 9 is negative 36, and negative 4 plus 9 is positive 5. Then divide A to the constants of the factors. So negative 4 divided by 3 and positive 9 divided by 3. Negative 4/3 couldn't be simplified, so remain as is, while 9 over 3 is simplified as 3, because 9 over 3 is basically 9 divided by 3. Since we still have fraction, bring up 3 beside x. Then, the final factors will be 3x minus 4 and x plus 3. The second given has factors of 3x minus 1 and 3x minus 2. The process of how I obtained this is by step 1, multiply 9 and 2, which is 18. And then rewrite the given as x squared minus 9x plus 18. Then think of factors of positive 18 that will sum up as negative 9. And that is negative 6 and negative 3. Because negative 6 times negative 3 is positive 18, and negative 6 plus negative 3 is negative 9. and then divide a to the constants of the factors. So negative 6 divided by 9 is simplified as negative 2 over 3, and negative 3 divided by 9 is simplified as negative 1 over 3. Since we still have fractions, bring up the denominators beside corresponding x. So bring up 3 of negative 2/3 and bring up 3 of negative 1/3. Therefore, the final factors will become 3x minus 1 and 3x minus 2. Again, like fractions, rational expressions are also bound to simplifying to lowest terms. Lowest terms helps a solver to work on problems less because of the base and lesser numbers involved. We simplify fractions by just factoring the numerator and denominator and canceling common factors with it. Still, you cannot cancel common factors on both numerator or both denominator. So let's have an example. Simplify the expression x squared plus 3x minus 10 over x squared minus 5x plus 6. So for step 1, we need to factor first the numerator and denominator. X squared plus 3x minus 10 is a GQT type 1. Then we can factor it by just thinking of numbers that if we multiply is negative 10 and if we add is 3. And that is negative 2 and positive 5. Because negative 2 times 5 is negative 10 and negative 2 plus 5 is negative 3. Then the factor of our numerator will be x minus 2, x minus 5. On the other hand, the expression x squared minus 5x plus 6 is also a GQT type 1. So we just think of factors of 6 that if we sum up will result to negative 5. And that is negative 2 and negative 3. Because if we multiply negative 2 and negative 3, it will become positive 6. And if we add negative 2 and negative 3, it will result to negative 5. So the factors of our numerator will be x minus 2 and x minus 3. So our rational expression in factored form will look like this. After that, we can now cancel common or same factors that was placed on numerator and denominator. Again, we cannot cancel common factors placed on both numerator and both denominator. Thus, in our example, we can cancel out x minus 2 of the numerator and x minus 2 of the denominator. So our answer will be remaining expression of x plus 5 over x minus 3.